Okay, the presentation is mainly titled as the paper, which is modeling and validating the class security model using Allaham. So as you know, it's really important that we have three main security policies, which are the confidentiality, the integrity, and availability. And it's important that a system should take in consideration all of these policies. By that I mean it's necessary for an organization to combine those properties in a well formatted way, so that they can function well and avoid any inconsistencies, so that no security breaches might arise as we progress in developing the system. So mainly LOE is a structural language for software design. It was developed at MIT. It's based on first-order logic, where it takes predicates, quantifiers, and variables, and it describes the system design. Okay. Then you have the LOE is actually the language, and the LOE analyzer is after you set all the first-order logic statements. You run them, and in order to check the models for objects and analyze them, and it translates them into Boolean formulas. Okay, and afterwards, you check if these formulas that associated to a specific model meets the specifications that were mainly assigned for the system by for the company or the institution that requested to model the security policy. So usually the plan is, before we develop any system, we need to describe the components and the interrelationships between those components, and by that we mean we have to build a model of the system, and by that we formalize that model in order to build a consistent system that respects the security, the three security policies, which are as I mentioned earlier, the confidentiality, integrity, and availability. So afterwards, the model needs to be analyzed and checked for possible bugs or inconsistencies, so that no security breaches or maybe bad data flows occur in the system. And this, of course, this stage should be done before the implementation, because usually the implementation is very costly for any system. So it's important to avoid any inconsistencies before starting the implementation. So as Professor Hayati presented a security model for a multi-level secure object-oriented database management system, he assigned the classification levels for each user, okay, and for each data item, it's assigned sensitivity level. And afterwards, it's important to the task of this security policy is to ensure that the users can access only the data items for which they have been granted permission. Okay. So, for example, X is granted permission to access object Y, okay, and otherwise, if it's not granted that permission, it won't be allowed to access it. So mainly the class security policy is more like a parent relationship, where a sensitivity level of a class must be identical to or lower than the sensitivity level of its subclass. So as in this example, we have the top secret, confidential, and unclassified before security levels, and in each level we have compartments. For example, we have as you can see, the nuclear, technical, and biological. So the top has the biological, the technical, and nuclear, and as we progress down the tree, we can see the different compartments, how they are distributed. So and then LOE it mainly checks for the consistent model. Okay, after we formalize the model, it checks for the consistencies and inconsistencies, and it reports it back to the one who's doing the writing the code. So this is a screenshot of the LOE implementation for the code and for the policy, and also it can generate this map where it shows each user has which role and which processes is allowed to access, the permissions and all the stuff related to the system in terms of permissions and access and roles. And it's important, like, to know, as the role-based access model is that, like, a subject can access only an object, okay, and perform an execution process on it if it has that permission. Otherwise, it won't be able to perform that command. So here's a sample output of like when the alloy shows inconsistencies. So it mentions that no instance found, like, and it's done in the last line, and like the next slide shows it like more clearly. Well, for example, this one we just we named the example and the brackets. So this one is called the predicate. So we run this predicate, and here, as you can see, like the instance found, and the predicate is consistent. So by that, like this model is valid. And this is another example where we ran this also the same example, but we added like another like executable violation, and it shows like no instance were found, and predicate may be inconsistent. So in conclusion, like in the paper we presented, like mainly we focused on the data integrity in different systems, like the health information system and different security systems that are used by the government. And Professor Harat mentioned that for 3 security agencies. Intelligence agencies, sorry. And yes, so and we, like as I said, we used Alloy to just design a model for the system and check for its inconsistencies before starting the implementation. And this is done by formalizing models using Alloy in a first-order logic statements that includes predicates and quantifiers that meets the specifications of the system. And then the model is analyzed, and as I showed you, like the screenshots, we can see like if it's, the model is consistent, that means it's valid, and if it's not consistent, then there's a security, there's a policy problem, or there's like the model needs to be redesigned again in order to meet the required specifications. That's all. Thank you.
I have a question.
Yeah, please go ahead.
What is the next step, the major next step that you'll be doing on this project?
So mainly, like as I told you, like we focused mainly on integrity in this project.
Mm-hmm.
But like hopefully, as we progress like more, we can apply the same policy on different systems. Like we mainly focused, as I told you, on 2 main examples, which is the health information system,
right,
and some security policies in the military institutions.
Okay.
So maybe we can like bring it more into the business-oriented field and just experiment it in real examples at like companies, maybe academic institutions.
There's actually plenty of work to be done in the health information systems. I'll be talking about that in a little bit. So
oh, okay.
That's not a bad area.
Yeah.
You have a question, Dr. Wu, anything?
Yeah, I think you give the comments. That's what I'm thinking. In the health information, because we have the sensitivity levels and the user of different priority, like the doctor, nurse, and so why do you want to use Alloy for the security check?
Actually,
so is that a special reason?
The thing is, like it allows you to code everything in a first-order logic, which is like it allows you to really experiment the system and check its policies before implementation. Like you can do some coding and start implementing the security policy, but that might reach you to a problem like later on when you detect a security breach or there's a problem with the policy, you need to recode the system again. So before going into this process, no, you can formalize the system, okay, into like set of statements, run them, and check if there's inconsistencies. Afterwards, we can go into implementation.
So what do you mean the system is your software system? So what's your definition of your system?
Okay, by system I mean, for example, we have, as you mentioned, like in the health information systems, we said like if a doctor can access only records that were reported by nurses.
So you need to first transform them into the program.
To first order logic statements, and then run them. So, for example, as I told you, like if a doctor can only access the reports that were reported by the nurses, okay, and the doctor can't access for example, the patient information. So, if you run a model, okay, where a doctor can access the patient information, this will report as an inconsistency, because this is not allowed.
Caine, do you have a question?
Yeah, one question, but you showed two screenshots.
Yep.
Seems very, very simple example.
Yeah.
But you give the model is pretty complex. You know, you have a big
Yeah,
tree.
yeah.
Can you run this on that model to see what the result is?
Yes, for sure.
Is there any inconsistency found in that model?
You actually, for sure, like sometimes there are some small inconsistencies you can't detect. That's why you have to test it. Like it won't report you all the inconsistencies in the system, but like you put the model and then you start testing. For example, as I mentioned, like a doctor can access a patient. Is it possible? Can, for example, a patient access information of other patient? Yes or no? But like you start to as test cases. Start by and to answer your question is here we can just a second. Okay. For example, here we can see the instance can be is in blue, which is a link.
Yeah.
When you press it, like it reports to you which model you are trying, or which in specific which entities are you trying to test. So you don't test like you test some specific
Consistency with
exactly, and then you do it for the overall system.
I'm just saying that maybe some model is very complex.
Yeah.
This consistency would not be very simple. Just
Right.
2 rules or 3
Right.
rules.
Exactly,
maybe,
for sure.
Maybe 50 rules
Exactly.
together. You can find one consistent because they involve all 50 rules.
Mm.
That's my saying,
okay.
because you know, it says A cannot access, can only access the information provided. B can only have it, but C cannot. D
Yeah, it's
everybody's involved. Cannot, you know, B and C no, they are consistent. C and D consistent. D and E
Yeah, but
consistent.
are they
But
all-
together it's not consistent.
Okay.
So that's my question, because you show the key
Yeah.
very, very complex.
Very
The
complex.
example is pretty simple. That's
Yeah.
my question.
Okay. So no, but like
That's the next stage in this research.
Next stage.
Yeah.
Okay.
Hopefully.
Okay.
You have a question?
No, thank you.
No questions, okay. Well, let's thank our
Thank you.
presenter.
Thank you very much.
So we're kind of winding down the,
Yeah.
yep, get it? That's right.
So it's the first paper.
Thank you.
Thank you.
Kind of winding down our first day here. I have 2 papers actually. They both have some security